In this exercise, we'll go over naming some substituted alkanes according to the IUPAC rules. So to name any substituted alkane, we're going to follow these steps 1 to 4. And doing this exercise, we're going to assume that you already learned the basics, the root names of the alkanes, starting from methane to decane, ondecane, etc. Because this is what we're going to use to name the parent chain and also the alkyl groups, the substituents that are on the parent chain as well. So the first time when naming a substituted alkane, or in fact any other organic molecule, is going to be identifying the parent chain. The parent chain is going to be the longest consecutive chain of the carbons. For example, here, if we just start from the left side, so we're going 1, 2, 3, 4, 5, 6, and 7. And so that will be the parent chain because there's no other possibility of having a longer chain. Let's say if I were to go 1, 2, 3, 4, 5, and 6, now we can see that I only have 6 versus 7, and that's why this is not a better option. And if I went, for example, from 4 to 5, then definitely this is not the longest chain either. So all you need to do first is find the longest parent chain, and this is just going to be a trial and error experiment. You just need to try, take a pencil, go over the carbons, count, and do it as many times as needed to find the longest possible chain. So once we do that, then we're going to know the name of the parent of this carbon. So 7 carbons, this means that this is going to be a heptane. So we can put here heptane. And this is the most important part of this molecule. So it's a heptane. The second part is going to be to find the substituents and name them. So these are going to be the other hydrocarbon chains that are on the parent chain. And in this case, when we find them, we're going to name them. And we're going to change the ending, the suffix from "-ane" to "-il". For example, here we have a CH3, and CH3 corresponds to the CH4. So it's 1 hydrogen less, that's the alkyl group, and it's going to change from methane to methyl. Here again we have another CH3, so this is also going to be a methyl. Okay, so we have numbered these from 1 to 7 to name the parent. But the thing is, you can number these from left to right, or you can go from right to left. And if I were to start from here, I would get 1, 2, 3, 4, 5, 6, and 7. Even though, of course, in both directions it's 7, but there's a preference. So this is mentioned in number 3. You gotta number these such that the first substituents, the first alkyl group, gets the lowest possible number. So if I number from the right side, then the first methyl is getting 3. So I'm gonna get 3 methyl and then the rest. If I'm starting on the other hand from the left side, so I'm gonna have 1, 2, 3, 4 methyl. So this will be 4 methyl. And in this case, we can see that the first option is better because the methyl is getting a lower number. If you happen to have a molecule that when you number it gives you tie, for example, if I have 2 metals here, it doesn't matter here if I start from here because I'm gonna have 1, 2, 3 and etc. Here also I'm gonna have 1, 2, 3 and etc. So whatever I do, I'm gonna get 2 methyl and then etc. In this case, we're gonna look for the second substituent. If I start here from the right side, I'm gonna get 1, 2, 3, so this will be 3 methyl. But if I start from here, I'm going to get 1, 2, 3, and 4 methyl, and that's why starting from this side will be better. So if you get a tie starting from the first substituents, then look at the second layer, and then the third layer, and etc., until you find a better option of giving the first substituents the lowest possible number. But for now, let's just go back and continue with our molecule. And here, because we found that the first option was better, we'll just erase this. And now we'll find the second substituent. So on position 4, we have another methyl. So we have 3 methyl and then we have 4 methyl. So we have 2 alkyl groups and this is the parent. Now at the end, we're going to put all of this together and put the substituents, the alkyl groups, in alphabetical order. In this case, the alkyl groups is the same. We have 2 methyls, so this part in the first example doesn't matter. So let's put this together. We're going to have 3, and if you have the same substituents on 2 positions, whether the same or different, you separate it with comma. So this is 3, 4 dimethyl you need to learn the prefixes such as mono, di, tri, tetra, and etc. So this is 3,4-dimethyl, and then we put the parent. If there is a word followed by the number, then we put this hyphen, the line. If it's just a consecutive words, we have dimethyl heptane, there's no need to do anything, just keep going. So this is heptane, dimethyl heptane. And this will be the full name of this compound. In the next example, this is what we have. We have a cyclic system that is connected to this straight chain here. And in this case, you want to number them. So we'll number, actually let's number from this one. 1, 2, 3, 4, and 5. And then we'll also number these. 1, 2, 3, 4, 5, and 6. Pay attention here. This carbon is in the ring. And if the carbon is in the ring, it does not belong to the straight chain. Meaning that you cannot do 1, 2, 3, 4, 5, 6, and 7. So this only belongs to the ring. Now I have 5 carbons in the ring and I have 6 here. In such cases, the one that has more carbons is going to be the parent chain. So here the parent is going to be hexane, and this part is going to be the alkyl group. So without being an alkyl group, this is cyclopentane. If this now becomes an alkyl group, this will be cyclopentyl. So cyclopentyl. Then you also need to put the number, the position at which the cyclopentyl is connected on the parent chain. So this is 1 cyclopentyl, no space, nothing here. Cyclopentyl hexane. I do want to mention here that depending on the source, sometimes there's a literature where they're taking the cyclic as a parent chain no matter how many carbons we have here. In that case, they're treating these as if this is the alkyl group and saying that this is hexyl cyclopentane or 1-hexyl cyclopentane, even though this is not necessary, because if it's only one substituent, then it's going to be on position 1. In this case, I would say just go based on the requirement of your instructor. If your instructor wants the cyclic to be the parent chain, then go that way. If your instructor requires to take the parent chain according to the one that has the most number of the carbons, then you follow that rule. Let's check here. So our first step is going to be finding a parent chain. I'll try to go right from here. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. It doesn't matter which way you go because you have 2 carbons on both sides. And this seems to be the longest parent chain. But now you can pause this for a second and think about, do you think we should start from this top left, go down, or we can go 1, 2, 3, and then end up having the 9 here? And remember, to answer this question, you're going to find the first substituent. In this case, this is going to be this methyl. And if I'm starting from here, then I'm going to have a methyl on position 2. So this will be 2-methyl. The other hand, if I started from the top, my first substituent is coming only at position 4. So that means that the correct way is going to be going from this side towards the left side. So then it's going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we'll erase this. And we'll look at the other substituents. So we have one metal in position 2. And if you look, we also have another metal in position 4. So we have 2-methyl, we have 4-methyl. And at position 6, we have this group. So here I have 1, 2, 3. This is isopropyl. So this is 6-isopropyl. Now I need to put the substituents before the parent chain. And to do so, we're going to look them alphabetically. So I have M, iso. Remember, iso is the only prefix that is not ignored. Right? So for example, if this was, instead of the isopropyl, you had 3rd butyl or secondary butyl, then you wouldn't look at the first letter of the prefix, then you would just look at the p, butyl. Here it's isopropyl, so we do count them as I. And that's why this is going to go before the M's. So in the final step, I'm going to write down that this is 6-isopropyl. I have a word here, and I need to separate this from a number with this line. So this is now 2,4, because 2 groups are the same, 2 metals, 2,4-dimethyl. Then the name of the parent chain, so 9 carbons, and that's nonane. So one way to look at this is why we're putting the parent chain at the end before the substituent is because the parent chain is more important And so this would be the more important part. Let's say this is a car, and then you have the adjectives before it. So this is your noun, these are the adjectives. So you have a red, blue, nice, wide, comfortable car. So these are describing the parent chain. That's why they go before the parent chain. And then after that, the parent chain is the noun. That's the most important part. And it goes after those, after the adjectives.